Hey guys, welcome to this episode of Pragmatic Software Engineering. Today we'll be talking about if statements. Now if you recall, if statements are one of the key things we use in our programmer's palette. They allow our code to act dynamically based on an input. So what does that mean? Well, let's get into it right now. I want you to recall in our last video we talked about classes and how classes represent something tangible in the world most of the time. As I said, these classes can be more esoteric, but for now we'll keep it in the sort of real-world, tangible examples. When you describe something, you describe it in terms of its attributes. A person has height, a person has weight, a person has eye color. You also describe something by the things it can do. So a person can jump, a person can record a video, that sort of thing. These are called methods, as I've told you in the last video. And when you create an object, let's say a person, right? When you create a person, this is called instantiation. Now, the reason this is important is because you could have many people. You're a person and I'm a person, but we're not the same instantiation. So, up till now, everything we've talked about an instantiation's attributes and methods. We've always required an instantiation in everything we've written, but that's not always the case. So not all code requires an instantiation to be run. You're going to see this keyword, static, and that basically means the code, or this code that you see, does not require an instantiation to be run. Rephrasing this in other terms, no information in the class is needed to run this function, or this code, successfully. And only two things in our programmer's palette can be static. The first are variables, the second are methods. And in the next couple slides, we'll go into detail of what a static method and what a static variable look like. A static variable is accessed via the class and not an instantiation. Therefore, a static variable can be shared across all instantiations. Let's think about that as an example. Imagine we're writing Space Invaders on Android. We think there's a lot of money that can be made selling Space Invaders on Android. And we want the game to end when all enemies are destroyed. So we care about this notion of how many enemies are left. Well, how would we do that? Would we just create some sort of variable in the main function and have that variable living there? That could work. It's a little bit clumsy though. Well, we could also attach a variable to the enemies class and call it static. And then what we can do is we can access that static variable anywhere we'd like. And when we kill an enemy, we can basically decrement it. Or if we start a new level, we can increment it. A static method is really hard to define, so I'll do my best. But a static method has no instance required. Again, it is shared across all instantiations. And static methods are used in many different places. You can use them in functions that you have to use in many places, like a utility function to convert from a comma-separated file to a tab-separated file. You could make static functions create new instantiations of a class, or you could use them as top-level functionality. So static methods should be used conservatively. They're kind of a exception to our object-oriented paradigm. And what it allows you to do, a static method is like this kind of cheat code you can use to run code without having any real dependencies on it. Like you don't need an instantiation to run it. So an example I can think of is designing Space Invaders again. You can start the game via a static method, and you can stop the game via a static method. I want to make sure I explain this, but a static method is kind of like this sort of God method that can do whatever the heck it wants. So you'll see a lot of static methods depending on the context of the program you're writing. If you write a program to be super object-oriented, you create a new game, right? And therefore, you never need to create a static function because you have that game object. But if you write your game without this, if you create Space Invaders without using all these object-oriented paradigms and trying to create, a game class, you probably will use static methods. Again, it's really hard to explain, but static methods are kind of this exception to the rule that us programmers use when we don't think we need an instantiation of something to run some code. So let's talk about some examples about some static methods and static variables. I think we should start with methods because there's a static method right here. This public static void mains. This is the function of the program that gets called on start. So this is the top layer of the code, right? There's nothing above it. Everything is below it. So to me, it makes sense that it's a static variable a static method because it really isn't subject to anything that controls it. It is like a top level piece of code that controls things under it. Now, if we want to start talking about static variables, we can add a static variable to our Jedi class that we created a couple videos ago. And what we'll do is we're going to really draw upon the example I just showed in the slideshow where we're going to create a number of Jedis and set it to 0, and we'll set this to be a static, right? Now, what we can do is our number of Jedis increments by 1 whenever someone calls the constructor. And so if we go back to this main class, we can create a new Jedi, and let's do Vader, and I don't know if I spelled it right, and then what was the last one? Oh, it's just 2. So if I create this multiple times, who's another good Jedi? Well, I think Baby Yoda is here. We'll do this like Lady Yoda. Oh, that sounds pretty funny. Baby Yoda, Lady Yoda. Now what we can do is we can print out the number of Jedis we have. So that's accessed again by the class, not instantiation, and num Jedis, right? And if we run this code, we should see 2. There you go. So if we return to static methods here, a static method cannot call a non-static method. So as an example, you might have written some code that looks like this. Public void do. And all we're going to, actually let's do public void say hello. And you just, you just print out hello world. And you want to call this in your main function. It won't work. The reason is this static code is not attached to any instantiation. Again, it's like this sort of God code that has nobody responsible for it. It's not encapsulated by anything. So you're wondering, why can't I run this say hello code? And the reason is this has to be static as well. As soon as I change to static, you'll notice that the error goes away, and when I run this, it successfully runs. I want you to also notice here that out is a static method. And if you look at this, really, there's only one system on a computer. It's the computer you're running it on. So the fact that the system has some sort of output and there's only a singular output and it is static, it makes sense because this system is effectively the playground we're working in. There can only be one system we're working on. So to me, it makes sense that this out is a static variable. Let's write some code that changes a string, and we're going to write it in 2 different ways. One that requires an instantiation of a transformer object, and one that is a static method. Let me open my project. We'll first start with the more object-oriented solution of creating a new class. Let's call it text transformer. And our text transformer is it's just going to require nothing to be instantiated. And there's going to be a public class that returns as a string, a public method that returns as a string called transform. And transform is going to take a string, and it's going to return that string in lowercase. I haven't seen this locale root thing before. That's all this piece of code is going to do. Very simple. Now, let's change our say hello function to require a text transformer to run. So let's create one inside this function, new text transformer, and we're going to text transformer dot transform hello world. And that's going to take our hello world and put it in all lowercase. Let's run it. Works. Now, we basically create a new class to do this. But you'll notice that we don't really require anything in this instantiation. We don't require any of the class's attributes or methods to produce a correct result for a transform. That means that we could also write this as a static method. So we do public static string transform string s, and we return exactly what we did in the text transformer. I'll even copy it. This is the same exact function. We've just did this in a different way. Now I can reference the transform without qualifying the name, which means I don't have to write main dot. Or if I wanted to, I could fully qualify the name, i.e. really spell out which class, which function to run. If we run this, we're going to get the same result. And this is just a basic example of a lot of things you're going to be doing as a programmer. There are going to be many different ways for you to finish this problem. Once you master the syntax, you'll be able to say, wow, the syntax isn't hard. It's really, how do I do this the best way possible? And that comes with time, obviously, and it comes as your intuition as a programmer matures. So here we've created a text transformer via an instantiation and also via a static method. Personally, if I was trying to be pure object oriented, I would use this instantiation. I think it's okay for me to write this static method here. One of the things we'll talk about soon is, testing our code, and I find that static methods are a little bit easier to test, but this is certainly still easy to test. So in conclusion here, we've really talked about what a static variable is, what a static method is, and how they differ from their instantiated cousins. So we know static means I don't require an instantiation to run, and we understand static variables can be very helpful for keeping track of, the things we need to know about a class. How many instantiations was the example we used are currently running. And we've talked about static methods and how they kind of break our object-oriented paradigm. We've also done something for the first time that I'm really excited about, because this is one of the most important parts about programming. We have talked about multiple ways to implement some feature. So we did this with a static method, and we did this with a text transformer class. As you mature, you're going to realize that there are a lot of similar problems where I can solve this in many different ways, but what's the best way to solve it? What's the most maintainable way to solve it? And what's the best way for this code to mature in the future? Well, hopefully, as you mature as a programmer, this will be an easier thing to bite off and chew. But that's really all we've learned today. If you like this video, please subscribe, like it, maybe send it to your friends. If you don't want to write me some scathing comments, go ahead. Please do. Thanks, guys. Bye.